In order to best read the report, for this example, we should start by looking at the graph. First, we need to check if the rumen pH is okay. The pH should be above 6, which it is in this case. But for the purpose of this tutorial, we're going to show how the pH increases when we change the milk yield. For that, we're going back to cow and TMR. If we change the milk yield to 30, then run the simulator again, you can see how the pH has increased. But to continue with this example, we'll set our milk yield back to 50. So, back in the report, we can see that the rumen guide graph shows the balance of fermented carbohydrate to fermented protein in the quick and slow microbial pools. Both of these values should be approximately 0, but as we can see, currently they are not. For the slow pool, it is above 0, averaging about 0.5, and for the quick pool, it is below 0, averaging about minus 0.5. For efficient microbial growth, that means a value of 0 in both pools, a certain amount of protein has to be provided with a certain amount of carbohydrate. You can see on the graph that when the line falls above 0, this will indicate that you need to provide more rumen degradable protein, RDP, and less carbohydrate, CHO. When the line falls below 0, you need to provide more CHO and less RDP. To optimize the TMR for a better, more efficient microbial growth, we're going back to the cow and TMR page. And we're going to add another feed here in ingredient 6. Lactose whey permeate, and here in ingredient 7, yeast. Now, if we run the report again, we will see that the blue and red lines are near 0, representing a more optimized TMR in terms of microbial growth. If we look at the next graph, labeled NH3R, it shows us the rumen ammonia concentration. A green line would represent an ideal value. A yellow line indicates that the level is high, and a red line shows a very high level. If the line is blue, then this indicates that there are not sufficient levels of ammonia present. The urea B graph is a prediction of the blood urea concentration. This graph uses the same color code as before. If the NH3 and urea levels are too high, this will affect fertility, making the cows less likely to calve. In the production and price section at the top right of the report, we can compare the achieved or simulated target values for milk yield, the use of feed, and the concentration. In the feedstuff section at the top left part of the report, we can see what a cow would eat from the TMR plus parlour feed. Notice that these are not the same as the amounts put into the cow and TMR page, but they are in the same quantity. In the nutrients section, we can analyse the quantities of different nutrients consumed by our cows. It's not the same as in the cow and TMR section of the model, since there is parlour feed added to the TMR, according to our feeding strategy. Towards the bottom of this section, we can find the prediction made by the simulator of 3 important dietary factors: the metabolizable protein, or MP, the glucogenic and the ketogenic. The glucogenic value represents what can be used to produce glucose in the cow's body, and the ketogenic represents what can be used as fat. For the metabolizable protein, the difference between the quantity and aimed is used to provide further glucogenic and ketogenic amounts, and then the excess glucogenic quantity over that aimed for is used to provide further ketogenic amounts. If the ketogenic quantity falls away from that aimed for, there won't be sufficient nutrients to make as much butterfat as expected. The rumen performance section has a lot of information in it. The key aspect to note here is the rumen raft. As we can see, the lower end of the scale has diets which are too loose. Below 3 is classed as too soft, and above that is considered as satisfactory. The minerals show what a cow would get from its diet in the way of macro and micro minerals. The same colour scheme is used, blue being insufficient, green being ideal, yellow being too high, and red being far too high. In this example, we're going to add some minerals to our diet. For that, we can go back to Cow and TMR page. Here we're going to add to ingredient 8, dicalcium phosphate, into ingredient 9, bicarbonate, and ingredient 10, calcimagnetite. Now we can run the simulator again, and we can see how sodium, calcium, magnesium, and phosphorus have turned green. Okay, so for now this is the end of the tutorial. I hope it's helped in giving you an overview of how the pH6 dairy simulator works. If you're interested in finding out more, please go to our website or drop us an email where we will be happy to answer any of your questions. Thank you for watching.